Josh, and I'm going to go over series parallel drawings using the schematic diagram. So the first thing we will do is draw out our schematic series parallel diagram, and we will label all the resistors in their proper locations. Plus, we will write down their values on the side to keep those handy. The one thing that we know in addition to the resistive values in this circuit is that the current through I6 will be 2 amps. Knowing that the current through I6 is 2 amps, we are then able to solve for the voltage that is across I6, or resistor 6. So we will take 2 amps, multiply it by 50 ohms, and that will give us a volt drop of 100 volts. We will then redraw the circuit with the intention of collapsing resistor 5 with resistor 7. To do that, we recognize that they are in series, and we will add resistor 5 to resistor 7 to get a total value of 215 ohms. Our next step will be to collapse the circuit once again to solve for the resistive value of our 3 and 4 together. And because they are in series, we add them for a total of 25 ohms. For our next step, we will redraw the circuit, and we're going to collapse R2 with our 3-4. So R2 is in parallel with our 3-4, and we'll use our inverse formula to calculate that resistive value, and we get a resistance of 13.636 ohms. Knowing this, we can then solve for the voltage across this resistor or collection of resistors, because we know that the 2 amps that flows through R6 is going to flow through this group of resistors. And this gives us a voltage of 27.27 volts. Our next step would be to find the volt drop across R5 and 7. Now, we can recognize here that R5 and 7 is in parallel with R2-4 and R6. Thus, we can add the volt drop across R2-4 plus R6 to get a total volt drop for R5 and 7 of 127.27 volts. And so it follows that the next thing we want to look for is the current through IR57, and we will take our voltage of 127.27 divided by 215 for a current of 0.592. And it's important that we review that any current that enters a node is that same current that leaves a node, recognizing that we have a current of 2 amps across R2 through 4 and 6 for a total current of 2.592 amps. Now note also that this total current is the current that is going to be through IR1. So we will then redraw the circuit and look for that resistance of R2 through 7 to find a total resistance of 49.1 ohms, remembering that they were in parallel. With that, we can recognize that it has that full voltage of 127.27 volts. And then we can take the current that we have of 2.592 and solve for the volt drop that does indeed remain. Recognizing that those two resistors are in series, we can then add those voltages together to get a total voltage for the circuit of 179.11 volts. It's at this point then that we can look at the values that we have found for our totals, recognizing that we have 179.11 volts for our total, and our total current is 2.592 amps. We can then solve for our total resistance by dividing our voltage by current, or by adding those resistive values together. And now comes the fun part, where we get to expand this circuit back out and solve for any unknowns that are remaining. If we look simply here, we know that we have the voltage, the resistance, and the current across R1, and that we have those same things across our grouping of resistors. So we can check off R1, we can expand the circuit to separate our R5, 7 and our R2 through 4 and 6. And we can keep writing all of those values that we do know, and we will proceed through this process until we get to the point where we have an unknown value, as we continue to separate those resistors apart, whether they are in series or in parallel. So we redraw it once again. We know that we have our R1, we know that we have our R6, and we see here that our R3 through 4, we don't have our current value, so we can solve for those current values by using our Ohm's law, and we will take the volt drop of 27.27 volts. We will divide it by the ohmic value for R2, which is 30 ohms, and subsequently we'll do the same thing for R3, 4, and that will give us the current that is across R2, as well as the current that flows through R3, 4. Now that we know the current value that flows through 3, 4, we can then find the volt drops that are across resistor 3 and resistor 4 individually by using Ohm's law. And so we will take the current, we will multiply it by the ohms, or the resistance, and then R3 and R4 are done. Our final step is going to be solving for the volt drops across R5 and R7. We can recognize here that we have indeed found the volt drops, the current values, and indeed we had the resistance of each one of the other resistors. And so we can take the current that is going through R5, 7, apply Ohm's law, multiply that current by the ohmic value, and obtain our volt drops for each one of those resistors. And that was the final step. So congratulations, you just walked through series parallel circuits. No matter how complicated these circuits get, you can keep the steps simple and always remember that you got this.